All right. So let's focus up here for a little bit. We're going to start talking about graphing lines and parabolas and absolute values, all that stuff we've been doing. All your phones are where they're supposed to be, right? Yoder? Thank you. All right. So the first thing we're going to look at is just our Cartesian coordinate plane. Just a quick review of everything there. We have our x-axis, the horizontal one. We have our y-axis, the vertical one. They intersect at the origin, which is the point 0, 0, right? You guys remember this stuff? When I plot a point, the point I plotted was -3, -5. It's called an ordered pair. The x-coordinate is the first one. The y-coordinate is the second one. You know, it's in alphabetical order. That's why it's called an ordered pair, right? And we have 4 quadrants that it gets split up into: first, second, third, and fourth. Just a quick review of, you guys know where to plot points and stuff, right? Simple, really easy. So the first thing we're going to do is find the distance between 2 points. So we're going to use the distance formula to find that. And the distance formula is d equals the square root of the x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1. So the 2 and the 1s, those are called subscripts. We're going to have 2 points. So the x2, y2 represents the second point. The x1, y1 represents the first point. And it really doesn't matter which one you make first and which one you make second. Just be consistent. All right, so the 2 points we're going to find the distance between are -3, this point, and 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. Those are the 2 points we'll use to find the distance. And then we just plug in the formula. Right, Fred? Okay. So since I put 7, 1 second, I'll use that 7, 1 as x, or 7 as the x2, and minus, and then -3 as x1. So then I'll use 1 as the second y, minus -3 for the first y. Any problems with what to put in where? Again, I could have made the -3 the second. I would have just gone -3 minus 7 and -3 minus 1. Just be consistent, that's all. It'll get you the same answer. So when I see minus a negative, though, what happens? Anybody? Becomes addition, right? So that's really 7 plus 3 and 1 plus 3. So 7 plus 3 is 10, and 1 plus 3 is 4. What's 10 squared? 100. What's 4 squared? 16. So the distance between those 2 points is the square root of 116, right? Now with me, I like to simplify it using radicals. So that's 4 times 29. So I can make it a 2 radical 29. You guys with me on that? We've done a lot of that already, right? Some of you might like just to put it in your calculator, the square root of 116, and get 10 point, we'll just round it to 8. That's fine too. I don't have a problem with you writing the decimal answer. Questions? You with me, Andy? So we had this a few years ago. Distance might have been in geometry, maybe. But we're just plugging in. Now, what you could do if you forget this formula, we could do this. What did I just draw? What kind of triangle? A right triangle, right? We got our right angle over here. All right. Basically what we just did, if we make this A and this B and define the C, yeah, I hear somebody saying it. A squared plus B squared equals C squared, right? Pythagorean theorem. That's all the distance formula is. You know, x2 minus x1 is the A squared. y2 minus y1 is the B squared equals the distance between them, the C squared, the hypotenuse, right? So if you forget the distance formula, you could draw yourself a little right triangle and just do A squared plus B squared equals C squared. Okay? Once I know what A and B is, and I square it and get that 1/16 equals C squared, what would I do to get the C? I would square root it. That's where that square root comes in. Okay? That makes sense? Any questions? All right, the other thing we're going to do and figure out between 2 points is also, or is called the midpoint. So we're going to use the midpoint formula to find the midpoint, or the point halfway between. And what you do there is this. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So the distance formula, you're subtracting them. Thanks for stopping in. See you tomorrow. You too. So remember, in the distance formula, we're doing subtraction of the x's and squaring them and then adding. In the midpoint, we're adding the 2 x's and the 2 y's and dividing by 2. All right, so if x1 was the -3, and x2 was the 7, and the y1 was -3, and the y2 was the 1. What's -3 plus 7? 4. What's 4 divided by 2? 2. And -3 plus 1 is -2 divided by 2? -1. So let's see if that's halfway. There's 2, -1. Is that purple point halfway between those two? Yeah. Okay? So you're going to have some of those problems today. Okay, Ozer? Just plug into the 2 formulas and find that. Those 2 answers, distance and midpoint, whatever they're asking you to find. Any questions so far? Okay, easy stuff, right? All right, we're going to graph some lines today too. So how do I graph a line? Y by itself, right? Isn't that what we've always done? So what do I got to do to get y by itself? Add the 2x. And that's where some of us made a mistake solving our inequalities the other day. Remember, when I move something, a term, over to the other side of the equation, I do the opposite, right? Go to the opposite side, do the opposite. So remember, that's why we're adding 2, right? Because it was subtraction. Some of us saw this with an inequality symbol the other day, and then we subtracted 2x again. All right, just little careless things. I think we're getting in a hurry, that's all. So I get y equals 2x plus 1. I like to put it in this form. What do we call that? Right, slope-intercept form, right? M is the slope, and B is the y-intercept, right? The y-intercept, meaning what, Evan? Yeah, where it crosses or where that number is on the y-axis, right? All right, so what I would do is go to 1 on the y-axis, and then I would make this into a fraction. What's another thing we talk about for slope? You guys remember seeing that before? Or hearing that? Rise over run. Rise is up and down, and run is right and left. Positive rise is up, negative rise is down. Positive run is right, negative run is left. We all know that, right? So, what do I do from here, Kennedy? Here's my equation. Very good. So I could keep going up 2 and over 1. What if I went down 2, negative? Go left 1, another negative. What's 2 negatives? Positive. So it's still a positive slope, right? So if it's slanted this way, left to right, going up, it's a positive slope. If it's slanted this way, going left to right, going down, that's a negative slope. So, we just connect our points. You guys remember how to graph a line, don't you? Okay. So there's our line, or our graph of y equals 2x plus 1. Okay? If you forget, you can always do what you first learned when you were first introduced to graphing. You were taught this. Remember that? Make an XY table. We always picked -2, -1, 0, 1, 2 for my X values to figure out the Y values. That's why we got Y by itself plugged in for X. So you'll get these points. -2, -3 would be the answer. All right? -1 would be -1. 0 would be +1. 1 would be 3. And 2 would be 5, right? 2 times 2 is 4, plus 1 is 5. So we could find those points that way too. What else do you have that you could graph on? Your calculator, right? So as long as you got y by itself, you hit your y equals button and put your 2x plus 1 in there and hit graph. If it's not showing up, remember what gets you to this screen is Zoom 6. We'll get you to that standard basic screen. Okay? So you can use your graphing calculator too to help you out. If you need some points to plot, because maybe you're not sure what those points are, what could you do in your calculator? Remember? Looking for the table of values. Guys awake? What's it say above graph here? Table. Hit the second graph. That'll give you your table of values you can use. Okay? When you're graphing. So lines are easy for us, aren't they? Yes? Yes, that's what I thought. You guys have done really well so far. Good math students. So let's continue to do that. Where's my other one? Did I get rid of it? I guess it was here. No, that's not it. I must have erased it. All right. I have to rewrite it. Where's it at? It is negative x squared plus y equals 1. What's this going to look like, this graph? Anybody know?
The x is squared.
Down like this. It's a parabola, right? When it's got x squared, those are parabolas that open up or down. Just get y by itself. Okay? Then you can put it in your calculator if you want. Or, again, if your calculator's not working, you can just do this. What's negative 2 squared? 4 plus 1. Negative 1 squared is 1 plus 1. 0 squared is 0 plus 1. 1 squared is 1 plus 1. 2 squared is 4 plus 1. All right, so negative 2, 1, 2, 3, 4, 5. Negative 1, 2, 0, 1, 1, 2, 2, 5.
Parabola.
There you go. Okay? Remember how to do parabolas. Again, get y by itself, you can use your calculator. All right, if we go to our table, second graph, there's the points that I used for my table. All right? So, when do we know if it opens up or down, our parabola? Anybody remember? Last year? This one opened up. What do we look at? The positive x squared, yeah. If your x squared is positive like this, it's going to open up. If this x squared was negative, it would open down, right? We call that the a value, right? The number in front of the x squared. All right. What if the y is squared? What's it look like? Good guess. Olivia said like a C or a parabola that opens sideways.
Parabola.
Yeah, sideways. When the y is squared, it's sideways. Out to the right, opens out to the right or out to the left. Okay? So what do I do if I want to graph it on my calculator? I have to do what to get y by itself? Square root, right? Izzy, you okay? Make sure Lily stays awake this second. Now, when I do that, what do I got to remember? When I take the square to both sides, when I'm solving stuff, what symbol? Plus or minus, yeah. So if I make an XY table, let's use nice numbers like 9, 4, 1, and 0. Why did I pick those? They're perfect squares because I'm taking the square root, right? So make things easier when you make these tables if you have to do square root of x stuff. Use those perfect squares. So what's the square root of 9? 3, but what symbol's here? Yeah, so plus or minus 3. There's 2 points. Square root of 4, 1, and 0, right? So when I go 0, 0, I go here. 1 positive 1 or 1 negative 1. 4 positive 2 or negative 2. 9 positive 3 or negative 3. There's my parabola. All right, my y squared originally was what? Positive. So it's going to open to the right. If my y squared in the beginning is negative, it's going to open up to the left. Now, when you try to do this on your calculator, you have to put the positive square root of x and the negative square square root of x. If you don't, you only get half of it. There's the positive half, and then there's the negative half, okay? So if you're going to do it on your calculator, which is fine with me, just remember you got to do the positive and the negative, a y squared one. Questions? All right. So far, so good, huh? All right, we have another one of these, an absolute value one. So what do you guys think? Do you guys remember from last year what these are? What they look like? Oops.
Absolute value.
Yeah, what happens with that?
I don't know.
You don't remember what they look like? All right, so,
Isn't it just,
no, it's not that one.
isn't it just the same thing?
No, they're not just straight either.
Y equals x minus 2?
All right, let's do this.
Or is there a plus minus in there somewhere?
What's negative 2 minus 2?
0.
0. What's the absolute value of
Wait,
0?
no. Negative 2 minus 2?
Oh,
That's negative 4.
well, you said 0. So
I
I
know,
just
I
thought
thought
you
you
knew
said
what you were
plus.
saying. So what's the square root of negative 4? I'm not the square root. Absolute value of negative 4. 4. Let's just go evens. What's 0 minus 2? Negative 2. Absolute value? 2. What's positive 2 minus 2?
0.
0. Absolute value?
0.
What's 4 minus 2?
2.
2. Absolute value? 2. What's 6 minus 2?
4.
4. Absolute value?
4.
4. All right, we've got some points. All right, negative 2, 4. 1, 2, 4. 0, 2. 2, 0. 4, 2. 6, 2. Or 4, 6, 4. All right. So it's not, it looks similar to a parabola, but it's actually a V. Absolute values are V's. Or upside down V's. When would the upside down V show up?
Negative.
Negative in front
Yeah.
of your absolute value. If there's a negative sign in front of your absolute value, it'll look like an upside down V. Now, if you want to do that in your calculator, you can do that. Let's clear those out. Sorry.
What?
Yeah. I think. I don't know. I don't remember. All right. So, to put this in your calculator, absolute value. All right. Anybody remember? No? Riley? No? Don't remember? Go to math. Move over to number. N-U-M. That ABS at the top means absolute value. Okay? So if you hit that, then put your X, what was it, minus 2? Now mine, I have to hit the parenthesis to close up the absolute value. Some of you with the newer ones, like Larimore here, when he hits that absolute value part, it'll make the straight lines for you. So it depends how new your calculator is. Hit enter, hit graph, and then you'll see your V. Okay? And again, if you need some values to plot, there's some table. Go to second graph for table. All right? So far, so good? We're going to be okay graphing lines, parabolas, and absolute values? All right? When we talk about domain, what are we talking about? The X values, right? And when I talk about the range, we're talking about the Y values. Okay, they might ask you some questions about domain and range. Okay, so that's stuff we should know. All right, last thing, sometimes they'll have us graph a line using the intercepts, or maybe parabola using the intercepts. Again, that just means where your graph crosses your x and y axis. What you need to remember about the intercepts are the x-intercept is always a point on the x-axis, or more points on the x. Sometimes there's more than one. All right, the y value is always what on the x-axis? 0. So if you're looking for an x-intercept, just plug 0 into the equation. Okay? If you're looking for the y-intercept, you're looking for points on the y-axis, right? Well, every point on the y-axis, what's the x value? 0. So when you're looking for a y-intercept, plug 0 in for x. When you're looking for an x-intercept, plug 0 in for y. And you can find them. Okay? So if we look at maybe our first example there, what was it? 2x, what was it? Y minus 2x equals 1. That was our first example. So if I add 2x to get y by itself, if I want the y-intercept, what's 2 times 0? 0 plus 1 is 1, which we knew anyway by looking at slope-intercept form, right? If I want the x-intercept, I put 0 over here for the y. So what do I do to get x by itself? Subtract 1, then what? Divide by 2. What point's that? Negative 1/2, right? So 0 for, or negative 1/2 for x, and 0 for y is right there. All right, if I go up 2 and over 1, or down 2 and left 1, is that going to land on there? Yeah. Okay, so you can use the x and y intercepts as graph also. All right, any questions? That's about it for today. Doing a little graphing. Distance formula, remember? Midpoint formula. There is your assignment. The picture is on Canvas. I got it put on last period before. I always forget the first period for some reason.